In this video, we show how to find the composition of functions and how to find the domain of the composition of functions. All right? The composition of functions is defined in this statement here. If we're given two functions, say f and g, the composite function denoted by f composed with g is defined as f composed with g of x equal to fgx. I like to think of this as, instead of putting an input, say x, into a function, say f, we're putting a whole entire function in as an input into another function. Right? And the domain of f composed with g is the set of all numbers x in the domain of g, such that g is in the domain of f. Now, let's look at a few examples of this. Right, let's try to do each of these questions here. It's a little bit, but this is how we can understand these concepts. So let's look at number one. We're given two functions, say f and g, and the question is, what is f composed with g evaluated on 3? So we go ahead and begin by writing down the definition of composite functions, which says that f composed with g of x is f gx. So here we're putting fg3. So notice we're inputting a number here. All right, and next we're going to go ahead, after we've applied the definition here, that was our very first step, is to apply the definition. See, we're applying what they had right here. All right, and then the next step is going to be, we need to find what is g of 3. So off to the side somewhere, we could figure out what is g of 3. Now, g of 3 means everywhere I see x in the function g, I'm going to replace x by 3. So here g was square root x minus 2, and where I see x, I'm replacing that by 3. So we can see that this will become square root of 1. 3 minus 2 is 1, square root of 1 is 1. All right, so now that we found g of 3, we're going to substitute that back in here, because g of 3 was 1, and now we can proceed further. Now the question is, if you substitute 1 into the function f, what is the value going to be? So we know that f was something squared plus 4. But instead of that x, we're going to put in the number 1. All right? So we put 1 in for x. Now 1 squared is 1. 1 plus 4 is going to give us 5. And that is our final answer. All right, so I hope you see. Now, anytime you are evaluating a composition function where there's just a number given as the input, then your answer is going to be a number, right? Now, let's do number 2 now. This time we're evaluating, we're inputting the variable x. So let's put that here for 2. We want to find out what is f composed with g of x. And again, by definition, f composed with g of x is fgx. Right? And what is g? G was, see, square root x minus 2. So I'm just taking my time, put in square root x minus 2. Okay? And now, the thing is to put this square root x minus 2 into the function f. And we know from above that f is something squared plus 4, right? And that's something. We're going to, instead of it being x, we're putting in this entire function g, which is square root x minus 2, right? Now, a square cancels out a square root, leaving x minus 2 plus 4, so that our final answer here is x plus 2 for the composition function. All right, now let's move to number 3. In number 3, we're trying to evaluate g composed with g of x. And again, the first step is to go ahead and apply the definition of composition, which says this. So here I'm substituting in g into the function g. Now the function g is, what is it? Square root x minus 2. And when I substitute this square root x minus 2 into the function g, it means that I'm putting in the function g is something minus 2. Sorry, let me put it like this. Something minus 2 all under a radical. And what is this something I'm putting in place of x? X square root x minus 2. So I'm going to put square root x minus 2 here. All right. And this is our final answer. We can't simplify this any further. All right, and now let's move to number 4, which is how to find the domain of f composed with g. For domain f composed with g is equal to what? So we're really trying to find out what is the domain of fgx. So I would start off this problem by first asking, what is the domain of f? What is the domain of g? If we look at our original function, f is a polynomial function. So any polynomial function, the domain is all real numbers. But for G, the domain is restricted to all values greater than or equal to 2. So to find the domain of any even root function, all we do is set what's under the radical greater than or equal to 0. So the domain for G is all numbers greater than or equal to 2. But how to find the domain of the composition function, right? So in this case, we would set what's under what the inside function, whatever is the inside function, we'd set that equal to what's excluded from the domain of the outside function. But nothing is excluded from the domain of the outside function. The outside function can be any real number, so that the domain of the composition function is going to be just what's excluded from the inside function, G. All right, so the domain of F composed with G is to infinity. All right, now let's look at number 5. We want to find the domain of the composition G composed with G. It's like saying, what is the domain of G, Gx? All right, so to find what the domain is here, I'm going to set the inside function, Gx, equal to what's excluded from the outside function. We already know that domain of G is all values greater than or equal to 2. Right? But we still have to find out if there's any restrictions on the composition function here. You know, G composed with G of x. So this is not enough to give us the domain of the composition function. All right, so what we do is we're going to set the domain of what's excluded from the domain of the inside function. Let me write this down. We're going to set what's excluded from domain of the outside function by outside function, I'm referring to the function furthest out here to the left, which is the outside function has to be any number less than 2. Equal to the inside function. And the inside function is g. So we're going to say here that square root x minus 2, which is the inside function. We set not equal to, but in this case, not equal to, but less than 2. Just 2 like this, right? And then we want to solve this, right? And once we solve this, that's going to be the value we get is what must be excluded from the domain in addition to the inside function, whatever is excluded from the inside function. All right, so let's see how we do this. So here I want to get x by itself, so I'm going to go ahead and square both sides. And this will give us x minus 2 is less than 4. So x is less than 6. So this x less than 6 along with x less than 2, both of these cannot be in the domain of the composition function, right? Now, by saying that x is less than 6, has to be less than 6, we've already included the in that statement or in that truth that x is definitely going to be less than 2. All right, so we're good by just saying that the domain, so these things are excluded from the domain. Domain of G composed with G. So the domain of G composed with G is everything other than that. And everything other than that is x greater than or equal to 6, right? And let me write this a little better. Set of all x such that x is greater than or equal to 6. Or in interval notation, we're going to say x is 6 to infinity. All right? Okay, let's look at another example. Let's look at this one. This will be our last question. All right? We're given two functions again, and we're trying to find out the composition and the domain of the composition. Now, the reason why I picked this problem is because these are rational functions. And when you're finding a domain of a rational function, sometimes it is a little bit tricky. And I just thought it would be helpful to go through these steps again. All right, so let's go ahead and find number 1. For number 1, we want to find the composition function f composed with g of x, and by definition, this is f gx. All right, and then the next step is we're going to go ahead and substitute our function g in our inside function into the outside function f. So when we do that, let's just write it down first. So x plus 2 over x minus 3. And now I'm substituting that function into f. So what is f, first of all? F is something minus 5 over something plus 1, right? So I'm substituting in for x this entire function g, right? So this is going to look a little sloppy. It's x plus 2 over x minus 3, and this is x plus 2 x minus 3, right? All right. And now we just have to clean this up a little more, because right now, as it is, it's a complex rational expression, and it's not in its more simplified form. So we have to simplify this a little further. So what we can do to simplify this is multiply the numerator and denominator by the LCD, which is what? X minus 3. All right, so when we the reason why this is okay is because we have it on top and bottom. So the net effect of what we're doing is nothing. I mean, this simplifies to 1. But it definitely helps us to make this not a complex rational expression. So when we distribute x minus 3 to the first term here, the x minus 3 on the bottom cancels out the x minus 3 on top, leaving us with x plus 2 minus 5x plus 15. After we multiply negative 5 times x minus 3, we get this negative 5x plus 15. And the same thing for the denominator. I'm multiplying x minus 3 to this first term, and the x minus 3's cancel. And then I'm multiplying x minus 3 to 1. So this is going to give us x plus 2 plus x minus 3. And now just cleaning it up a little more, this is going to give us negative 4x plus 17, 2x minus 1. All right, and that is our final answer. All right, now let's do number 2. Okay, here we want to know the domain of F composed with G. Let's first start off by finding out what is the domain of F. Domain of F is what? Domain of F, you can see that we just look at the denominator. What must be excluded from what value must be excluded from F is negative 1. So the domain of F is all numbers except negative 1. All x such that x is not equal to negative 1. Because if x is negative 1, the denominator would become 0. So we have to take that value out of this function. It can never be evaluated at x equal negative 1. And what is the domain of G? Domain of G is all numbers except x equal 3. right? And then now, next, okay, the way to find the composition, it's not enough, again, to say this is the domain of that composition. That wouldn't be that would be false. What we have to do is set the inside function equal to what's excluded from domain of the outside function. That is, the inside function is what? X plus 2 over x minus 3. I'm setting that equal to what's excluded from the domain of the outside function. The thing excluded from the outside function, domain of outside function, is -1. So next we solve this. X plus 2 after multiplying both sides by x minus 3. After rearranging for x, we're going to get x equal 1/2. So this and the inside function, whatever is excluded from the inside function, which is 3, these cannot be in the domain. Therefore, domain of G, domain of F composed with G, rather, is the set of all x such that x is not equal to 1/2 and x is not equal to 3. All right. I hope you found this video to be helpful. If so, like and subscribe. What we did here is the math of numbers and symbols, but we feel that math is order in the broadest sense.